Hi students, this is Mr. Yao. In this lesson, we are going to talk about 4.9a, where we will learn features of quadratic functions and also start getting into different forms of quadratic functions. So first, let's begin with the definition for the different forms of quadratic functions. Quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c. And a can't be 0 because if a is 0, then we have a 0x squared, then that means we don't even have an x squared. And of course, that won't be quadratic. So a can't be 0. And this form is called the standard form. We have seen it before. When we learned about using the quadratic formula, we had to make sure to put everything into the standard form. It was a standard form equation instead of standard form function. Next, intercept form. F of x equals a times x minus b times x minus q. And same thing, a can't be 0. The p and q, they're both going to be part of the intersect, x-intercepts. Now, some books will call this the factored form. I personally prefer to call it intercept form because even though it looks like it's just factored, but it's a bit more than that. Let's say we have a question that is 6x squared plus 5x minus 6. Let's say that's our function. And you can factor it to be 2x plus 3 times 3x minus 2. But the issue is, you see, they don't exactly give us the x-intercepts. We need to keep solving it to find the x-intercepts. But that leads us to x-intercept being a negative 3/2 and a 2/3. Which if we want to directly find it, we can't just use that, which is why in this form, you see, if we want to use the intercept, we're going to keep that 6 in the front, which is the a, which is just like the a in the standard form. Because in order to get this negative 3/2, we basically divide everything by 2 in the first parentheses and divide everything by 3 in the second parentheses, and that's how we actually get a 6 in the front, which was the leading coefficient. So it's a bit more than just a factoring. That's why I prefer to call it intercept form. Lastly, vertex form. Of course, that means we have a vertex. A times x minus h then squared plus k. It's easy to find a vertex, which is h comma k. But it's the same thing. We have this leading coefficient a in the front. Later in this whole 4.9 lesson, we're going to convert in between standard form, intercept form, and vertex form. But now let's define something else. Zeros of a function. You're actually going to be dealing with this more and more even next year because you're going to learn more functions. Any functions we work with, you're going to need to identify the zeros. The zeros of a function are values of the input x that makes the output f of x equal 0. Or in other words, zeros are when y equal 0. And that's why zeros could also be called the x-intercepts, solutions, or roots. And we typically write zeros as ordered pair, but in a lot of different situations or different questions, you may also see them just written as solution. It's just the solutions are separated. That's also acceptable. And when we take square root to solve, the zeros could actually appear as roots. And on the graph, it's x-intercepts. If it's an equation, it appears to be the solutions. We find zeros of a function by first setting the function to 0. So you see, we change the function into an equation basically, and then solve the equation by completing the square, factoring, or quadratic formula. These are the 3 different methods that we have learned. And here's the thing, since 0 is also x-intercepts, and when we graph, we typically graph real numbers, and that's why only the real solutions are our zeros. If we're not getting real solutions, then that's called no real zeros. But let's quickly recap what different situations we may see to use the different methods to solve the quadratic equation. Factoring, of course, if you just have like ax squared plus bx, for example, you don't have the number on the end, well then factor out the x. That's factoring. Then if you set it equal to 0, for that, you for sure should actually go with factoring because quadratic formula is going to take longer. Completing the square, well, if you just have, say, like ax squared plus c equals 0, you don't have the middle term, then it's very easy to isolate the x squared. Then that's where you should actually use a completing the square, or in other words, taking the square root. In the other situations, you have just the normal standard form, use the quadratic formula. So now let's have a look at a few examples to identify the zeros. Example 1, we're going to set it equal to 0. and then we are going to solve it. 9x squared plus 15 equal to 0. You see, it's x squared is very easy to isolate. We don't have a term bx. We don't have just the x. So subtract the 15 over. We got 9x squared equals negative 15. Then divide both sides by a 9. We got x squared equals negative 5 over 3. Negative 15 over 9 simplifies to be negative 5 over 3. And now here's the thing. As soon as we see that and you think about taking square root, well, you're taking square root of a negative number. So that's guaranteed to end up with a complex solution, which is involving an I. So you already know it's no real zeros. But let's still finish solving just as practice. And my recommendation when you take square root of a fraction, just take square root on the top and the bottom separately already. So you're going to get x equals plus minus. The top is a square root of negative 5, so it's I square root of 5. The bottom is a square root of 3. But of course, you need to simplify that. So you need to multiply the top and the bottom by an extra square root of 3 to get rid of the square root. So final answer, plus minus square root of I square root of 15 over 3. Some of you on the quiz made a mistake that you see, oh, square root of 3 times square root of 3. I got rid of something. Well, you didn't get rid of everything. You only got rid of the square root of symbol. So it's still going to be a 3 on the bottom. Okay, next, same thing. Equals 0. 7x squared equals 17. X squared equals 17 over 7. So I can take a square root on the top and on the bottom. So x equals plus minus square root of 17 over square root of 7. And then same thing, we're going to multiply the top and the bottom by a square root of 7. And my x is going to be a positive square root of 19 over 7 or a negative square root of 19 over 7. A lot of time when we write zeros, we do kind of write them separately. And in this case, even though you're like, wait, but that's not just like a fraction. Well, radical is still real number. Radical is irrational number. In this case, that's still real number. So these are going to be our zeros. Number 3. Well, set it equal to 0. You see, we don't have the number on the end, so it's very easy to factor that. We can take out a GCF, which is 2x, and then x plus 7 equals 0. We're going to get two answers, either x equals 0 or negative 7. There you go. That's example 3. Moving on, example 4. Set it equal to 0. You can see there's a GCF we can take out, or we can just divide everything by a 2, which is the GCF. We're going to get x squared plus 10x plus 25 equals 0. For this one, you see it's x squared in the front. Even though it's not just x squared, it still has an 10x. You can still choose to complete the square because it's going to be easy. Or you can choose to factor. After factor, it's going to get us x plus 5 times x plus 5 equals 0. Both of them is going to give us the same 0, which is x equals negative 5. For number 5, set it equal to 0. And just by quickly thinking 3 times 5 is a 15, you can find two numbers that multiply, that actually adds up to a negative 2 with a 15. So that one you can't factor, which is why we have to use the quadratic formula. But before that, let's identify our discriminant. Negative 2 squared, so b squared minus 4ac. That's our discriminant. Negative 2 squared minus 4 times a 3 times a 5. That's going to give us a negative 56. As soon as you see the discriminant is negative 56, that means if you use the quadratic formula, you're going to have a negative 56 under the square root. That's a negative number. So you for sure will end up with a complex solutions. So you already know the conclusion is no real zeros. But let's still actually, as practice, find the answer. Negative b is a 2 plus minus square root of negative 56 is a 2i square root of 14 all over 2a, which is a 2 times 3. That's a 6. Separate the fraction to simplify, we got a 1/3 plus minus I square root of 14 over 3 again. And that, for sure, these are two complex solutions, so there are no real zeros. That's example 5. Moving on. Now we're going to start converting between different forms. We're going to start with standard form to vertex form. If a quadratic function is given in standard form, which again, to remind you, that is ax squared plus bx plus c, we're trying to change it into the vertex form, which is fx equals a times x minus h squared plus k. So that means we need to complete the square to be able to find this perfect square. So we're going to review the process of completing the square with standard form quadratic function. So here you go. F of x equals ax squared plus bx plus c. The first step, we are going to divide everything by a. There's a typo. There shouldn't be this over a in here. Since we divide everything by a, the first part is just a is gone. So we're left with an x squared. So we have dealt with ax squared plus bx plus c equals 0. And then just complete the square. The first step is going to subtract the c over. Well, actually, we're going to divide everything by a, then subtract c over. But in that case, we're going to leave a space to complete the square. Here's the issue for this. We don't have another side to move the c. It's just inside the parentheses or outside the parentheses. So we're going to keep the c there, and we are going to create a space inside the parentheses. But we can't just add an extra number and call it good. We're still going to need to balance it out. So whatever we added right here inside the parentheses, we are still going to need to subtract it on the end, so the whole thing is still balanced. Now let's see if you remember how to find the number to put in the space. We need to take the middle, which is the b over a, divided by 2. That is b over 2a. And then we are going to square it. b squared over 4a squared, and that is going into the space. So we got f of x equals a times x squared plus b over a plus b over ax. Keep forgetting the x. Okay, and then plus b squared over 4a squared. We're going to plus the c outside. But now we need to subtract something to balance everything out. This is the extra thing we added, but we didn't just add a b squared over 4a squared. We also have an a outside the parentheses. So we actually added a b squared over 4a squared times an a. We're going to need to subtract that. It's going to be subtract b squared over 4a. Because 4a squared times the a is going to leave a 4a on the bottom. It basically cancels out an extra a. Okay, next, we're going to need to write it into perfect squared form. So, of x equals a still outside. And this is what we're going to need to put into the perfect square parentheses. X plus b over 2a. And then squared plus. Well, this is c over 1. We can't just keep them separate. We're going to need to combine them. So that means combining two fractions, we need a common denominator. Between 1 and 4a, the common denominator is 4a. We're going to need to multiply everything by 4a for the first part. That means the common denominator is 4a. On the top is a c times 4a, so we have 4ac. And then we have the minus b squared. Well, now the whole thing looks a bit more like our quadratic formula. But let me remind you what the form we're trying to get to. We're trying to get to vertex form is a times x minus h squared plus k. So a is already there. That means this middle part is going to be our negative h. If negative h is b over 2a, that means our h has to be a negative b over 2a. That's one thing you always have to be careful, because the vertex form is a minus h. So whatever is inside the parentheses, you always have to use the opposite. And then k, of course, is everything on the end, and that is 4ac minus b squared all over 4a. Now let me remind you, our quadratic formula is negative b plus minus square root all over 2a. Well, there you go. The first part, negative b over 2a, is our h, which is basically the vertex. We are going to practice more with converting between standard form to from standard form to vertex form in the next lesson. So that is everything for this 4.9a lesson. Thank you.